Assalamu alaikum, my dear students. I welcome you again with another video lecture on gravitation. In this video, we will talk about free fall and free fall acceleration and calculation of acceleration due to gravity. Then we will calculate the value of g on Earth and value of g on Moon. Firstly, let me talk about free fall. What do you mean by free fall? Think of a situation when a ball is thrown upwards. Okay? When you throw a ball upwards, it goes up, and after attaining a certain height, it starts falling down. And but the question here is, what is the cause that it falls down? It falls downwards. The ball falls downwards due to the Earth's gravitational force, as you already know it. The falling of a body from a height towards the Earth under the influence of only gravitational force of Earth is called a free fall. Okay. If there is no other influence on the body, if for example, this is a body, I throw this body upwards, okay? I throw this body upwards and this goes up in the air, up in the space. If there is no other force other than gravitational force, okay, and this ball will come down after attaining a certain height, okay. If suppose this is the ground, okay, and it will finally fall on the ground. If there was no other force, for example, if there was no wind, if there was no other force, no other external force which acts on this body, the only force acting on the body is a gravitational force. If this is true, then this is called the free fall. Okay. तो अगर ये एक बॉडी है, इस बॉडी को मैं एयर में थ्रो करता हूँ, और अगर ग्रेविटेशनल फोर्स के बगैर कोई फोर्स नहीं है, फॉर एग्जांपल विंड का फोर्स होता है, किसी और चीज का फोर्स हो सकता है, तो अगर वो फोर्स अब यहाँ पे इस पे एक्ट नहीं कर रहा है, इस बॉडी पे एक्ट नहीं कर रहा है, तो उस वक्त हम कहेंगे कि दिस इज द फ्री फॉल, ये फ्री फॉल है. फॉर एग्जांपल आप जो एक पेपर शीट थ्रो करते हो, ओके, इफ यू थ्रो द पेपर शीट अपवर्ड्स, ये पेपर शीट इस पे कौन सा फोर्स एक्ट करता है? एक तो ग्रेविटेशनल फोर्स, लेकिन एक और फोर्स इस पे एक्ट करेगा, दैट इज द फोर्स ऑफ एयर. फोर्स ऑफ एयर भी इस पे एक्ट करेगा. आप देखते हो कि जब एयर होता है, जब वो ब्रीज चलती है, तो ये जो पेपर है, ये जो है इस पे वो ब्रीज या इस पे वो विंड या एयर का फोर्स एक्ट करता है, और वो एयर का फोर्स जो है इस पे दैट फोर्स विल रेजिस्ट इट टू फॉल ऑन द ग्राउंड. वो इस पेपर को रेजिस्ट करेगा, यानी कि वो उसको अपोज करेगा ग्राउंड पे फॉल करने से. I will show you an activity. What is this free fall?
Cameras on, 2, 1, release.
Exact. They came down exactly the same. Wow.
Look. Watch right there. Look how they hit right there.
Exactly.
You're back on silent.
Exactly the same.
Feathers don't move, nothing.
That's just brilliant. Isaac Newton would say that the ball and the feather fall because there's a force pulling them down, gravity. But Einstein imagined the scene very differently. The happiest thought of his life was this. The reason the bowling ball and the feather fall together is because they're not falling. They're standing still. There is no force acting on them at all. He reasoned that if you couldn't see the background, there'd be no way of knowing that the ball and the feathers were being accelerated towards the earth. So he concluded they weren't.
I hope you got this concept very well. So, but earlier it was believed that this acceleration was greater for heavier bodies, and scientists believed that the lighter objects fell slowly, where heavier objects fell faster if they were dropped from the same height. But with this experiment, it was disproven, and earlier it was disproven by Galileo with his own experiment, and then later on it was experimentally proved. So hence it was concluded from this experiment that the acceleration with which body fall towards the earth is independent of their masses, as you have seen. If I drop the 10 kg mass and 1 kg mass, this is 1 kg and this is 10 kg, for example. If I drop these under free fall, they will strike the ground at the same time. Okay, that means this does not depend on the masses. The free fall doesn't depend on the masses. And one thing to remember here is that जब भी ये ऑब्जेक्ट्स ट्रैवल करते हैं, यानी कि डाउनवर्ड्स ट्रैवल करते हैं, सो देयर इज एन एक्सेलरेशन, ठीक है ना, स्पीड बढ़ती जाती है. पहले इनकी स्पीड थोड़ी सी कम होगी, फिर जो ही ये ग्राउंड के पास पहुंचेंगे, यानी कि ग्राउंड के नज़दीक पहुंचेंगे, तो इनकी स्पीड जो है बढ़ती जाएगी. ओके, द स्पीड विल इंक्रीज, एंड इन दिस वे जब स्पीड इंक्रीज होती है, दैट इज एक्सेलरेशन. तो बॉडी एक्सेलरेट होती है, ठीक है ना. सो दिस एक्सेलरेशन इज कॉल्ड द एक्सेलरेशन ड्यू टू ग्रेविटी. तो इस एक्सेलरेशन को हम कहते हैं एक्सेलरेशन ड्यू टू ग्रेविटी. ये जो एक्सेलरेशन यहाँ पे बॉडी जो एक्सेलरेट होती है, तो दिस एक्सेलरेशन इज कॉल्ड एक्सेलरेशन ड्यू टू ग्रेविटी. एंड all the objects that are freely falling, that means freely falling objects fell with the same acceleration. Okay, freely falling objects जो भी है, इनकी same acceleration होती है, and they fell with the same acceleration. 1 kg भी इसी acceleration से fall करेगा, and 10 kg भी इसी acceleration से fall करेगा. And it was concluded that the acceleration with which these bodies fall towards the earth is independent of their masses. This means that that all bodies, hollow or solid, big or small, fall at the same rate. तो आम कंडीशन में जहाँ पे हम एक्सपेरिमेंट करते हैं, फॉर एग्जांपल हम क्लास में एक्सपेरिमेंट करते हैं, या अपने रूम में एक्सपेरिमेंट, या बाहर एक्सपेरिमेंट करते हैं, हम क्या करते हैं, एक दो शीट्स लेते हैं, ठीक है ना. एक शीट को हमने एक रोल बनाया या एक बॉल बनाया, ठीक है, और एक शीट को हमने ऐसे ही रहने दिया. और जब हम दोनों को फॉल करते हैं एक ही टाइम पे, तो जिस शीट को हमने बॉल बनाया है वो शीट जल्दी जो है ग्राउंड पे पहुंच जाता है, और जिस शीट को हम ऐसे ही रहने देते, फ्लैट रहने देते, तो वो वो जो है देरी से ग्राउंड पे पहुंच जाता है, ग्राउंड पे फॉल होता है। दिस इज बिकॉज द रेजिस्टेंस ऑफ एयर, क्योंकि उसका जो एरिया होता है, दैट एरिया इज ग्रेटर, फ्लैट शीट का एरिया जो होता है दैट एरिया इज ग्रेटर, तो ग्रेटर एरिया पे ग्रेटर एयर रेजिस्टेंस जो है एक्ट करेगा, एयर का जो फोर्स है वो एक्ट करेगा, और इसीलिए वो देरी से या लेटली ग्राउंड पे पहुंच जाता है। दिस इज द रीजन, बट if we drop that two objects in vacuum, as you have seen in the experiment, if there is a vacuum, if there is no air, so if we drop them in free fall, they will fall at the same time. So this is the difference between the free fall and when there is no free fall. So फ्री फॉल जब होगा वहां पे मास और एरिया और किसी चीज पे डिपेंड नहीं करेगा, एंड फ्री फॉल या जब दूसरे फोर्सेस एक्ट कर रहे होते हैं, फॉर एग्जांपल एयर के रेजिस्टेंस, तो वहां पे एयर के रेजिस्टेंस हमें कंसिडर करनी पड़ेगी। तो एक चीज हमें याद रखनी है कि व्हेन ए फ्रीली फॉलिंग ऑब्जेक्ट फॉल्स टुवर्ड्स द अर्थ, देयर इज नो चेंज इन इट्स डायरेक्शन में कोई चेंज नहीं आती, ओके, बट द वेलोसिटी चेंज, यहाँ पे वेलोसिटी चेंज होती है। जैसे हमने एक्सपेरिमेंट में देखा कि वेलोसिटी यहाँ पे चेंज होती है, स्पीड इसकी चेंज होती है। तो जब वेलोसिटी चेंज होगी इसका मतलब यह है कि द बॉडी इज इन एक्सेलरेशन, द बॉडी एक्सेलरेट्स, यहाँ पे बॉडी एक्सेलरेट होती है, and Earth's gravitational force is the cause of acceleration, okay, produced in the freely falling bodies, and therefore the acceleration produced is called acceleration due to gravity. तो इस acceleration को हम कहेंगे acceleration due to gravity, क्योंकि gravity की वजह से acceleration होती है, इसीलिए इसका नाम acceleration due to gravity पड़ गया, and it is denoted by small g, okay, small g से हम इसको denote करते हैं। So small g denotes the acceleration due to gravity, and the value of g does not depend on the mass of the body. Mass पे depend नहीं करता, but although it will vary slightly from place to place, okay, and its average value is इसका जो है it is 9.8 meter per second square. 9.8 meter per second square. This is the average value of g. So what does the g mean? 9.8 meter per second square. This is acceleration. It means that the velocity of the body increases by 9.8 meter per second every second. Okay, after every second the acceleration will increase by this amount, 9.8 meter per second. So if it is dropped from a certain height. Similarly, if the body is projected towards its velocity decreases by 9.8 meter per second square. So if it is projected towards upwards, okay, if it's projected upwards, and its velocity will decrease by the same amount, 9.8 meter per second square, okay, its acceleration will decrease with the same amount. So if the acceleration decreases when we project this object upwards, this acceleration will decrease by 9.8 meter per second square, and we say that the body undergoes retardation. The body undergoes retardation. Let's now calculate the acceleration due to gravity. This means let's now calculate the value of g. How can g be calculated? If a body of mass m, for example, here is a body of mass m, it has mass m, and it is dropped from a distance r from the center of Earth. For example, this is the Earth, and its distance from the center of the Earth is r. Okay, if this distance is r from the center of the Earth, for example, this is distance r, and this object is dropped from the distance r, okay, from the center of the Earth, and this Earth has mass m. If suppose this Earth has mass m, and we know from Newton's law of gravity, the force will be given by the formula G m m divided by r square. Okay, this m is the mass of this small object which I dropped, and this m is the mass of this Earth, and r is the distance between the two objects. Okay, and जब भी हम distance measure करते हैं from the Earth, we take the center of the Earth. हम center of the Earth से measure करते हैं. Okay, if अगर एक body Earth पे है, ठीक है ना, Earth पे rest कर रही है, तो उस body और इस Earth के दरमियान जो distance है वो हम center of the Earth से लेते हैं, यानी कि हम radius of the Earth लेते हैं उस वक्त. So let's calculate. The force exerted by Earth produces an acceleration. Okay, it will produce an acceleration in the body due to which it will move towards it. And from Newton's second law, we know from Newton's second law. We know that force is equal to mass times acceleration. Okay, this is from Newton's second law of motion. So therefore the magnitude of gravitational force, this F, okay, will be equal to the product of mass times acceleration. So this F will be equal to mass times acceleration, because here it's force, and here it's also force. So this force will be equal to mass times acceleration, and here the acceleration is acceleration due to gravity. That means g. Okay, so this acceleration is g. This is acceleration due to gravity, because it is because of this we have dropped this object, and the object has accelerated because of gravity, acceleration due to gravity. So I can write F here as m times, and acceleration here is acceleration due to gravity, m times g. F is equal to m g, where g is acceleration due to gravity. So from here I can put the value of F is equal to mg. So mg is equal to g m divided by r square. Okay, mg is equal to g m divided by r square. So I can calculate the g here, which implies that g is equal to g m and m gets cancelled here. Okay, m and m gets cancelled here, so I can calculate the value of g is equal to g m divided by r square. Okay, so g is equal to gm divided by r square. So this is the value of g, where this g is gravitational constant, and this m is mass of the Earth, and here it's r square, and this r square is distance of the body from the center of the Earth. Okay, distance of the body from the center of the Earth. यहाँ पे एक चीज नोट करनी है कि ये जो r है, अगर ये बॉडी यहाँ पे होती, यानी कि ग्राउंड पे होती, तो यहाँ पे हम डिस्टेंस क्या लेते हैं, रेडियस ऑफ द अर्थ, क्योंकि हम सेंटर ऑफ द अर्थ से ये मेजर करते हैं. सो अगर अगर जो है ऑब्जेक्ट्स हम ड्रॉप करते हैं नियर द ग्राउंड, ठीक है ना, नियर द ग्राउंड हम ड्रॉप करते हैं ऑब्जेक्ट, तो वहां पर अप्रॉक्सीमेटली हम रेडियस ऑफ द अर्थ डिस्टेंस लेते हैं, क्योंकि हम ये जो डिस्टेंस है ये हम नेग्लेक्ट कर सकते हैं।